In this video, I'll be showing you how to use the chain rule in two different ways to differentiate a function. The first way is how we all get taught and practice the chain rule, which is the full step-by-step showing you working out method. And the second way is a quicker and much easier method. Now you want to know how to use both of these methods for your Saxon exams. When a question is worth 1 mark, then you'd use the quick and easy method because you don't want to waste time going through the whole process of showing you working out. But if the question is worth 2 marks, then you're going to need to know how to show you working out to differentiate the function using the chain rule. So firstly, how do you know when to use the chain rule? Basically, you use the chain rule whenever you have a function that is raised to a power. For instance, if we have y is equal to some function f of x, and this is raised to a power n. Now this power n, it's normally not 1. It's usually a big number like 3, 4, 5, 7, 10, 20, etc., etc. Or it can be a fraction power. So n can be a half, or a third, or a quarter, or a fifth, or 6 on 5, any fraction. Or it can be a negative number. It can be -1, -2, -5, -7, etc., etc. So what you want to look for is for a function that's raised to a power, and the power is not 1, and it can be a fraction, or it can be a negative number. And so that would be a clue for you to use the chain rule. To apply the chain rule, we need to use the formula dy dx is equal to dy du times du dx. And the way I remember this is that I treat the right hand side as two fractions being multiplied to each other, and so the two du's would cancel out, leaving just dy dx. And so the first step to using the chain rule is to rewrite the given function in power form, if it's not already written in power form. What do I mean in power form? Well, if we want to differentiate the square root of a function, let's say y is equal to the square root of some function f of x, then in power form we can write this as y is equal to the function f of x raised to the power of a half. Or if we have y is equal to 1 on some function, and this is raised to the power of 3, then in power form we can write this as y is equal to the function f of x raised to the power of -3. This is an important step, so make sure that you can rewrite the function in power form. Once you've got the function written in power form, then what we do from here is that we let u equal f of x. And so du dx is going to be the derivative, which is f dash of x. Now since we let u equal f of x, we can write the function y in terms of u. And so we can write that y is going to equal u to the power of n. And so dy du, deriving this, is going to be n times u to the power of n minus 1, which is simply using the power rule to differentiate. We now have both dy du and du dx, so we plug this into the formula. And so dy dx is going to equal dy du, which is n times u to the power of n minus 1 times du dx, which is f dash of x. And the final step is to replace u back to its original function, which was in terms of x. And so this is going to be n times f of x to the power of n minus 1 times f dash of x. Let's do an example to see how this works. Let's say we have the function y is equal to 1 on 2x cubed plus x to the power of 2. And so the first thing we need to do is rewrite this function in power form. And so we can write this as y is equal to 2x cubed plus x raised to the power of minus 2. And now we have a function raised to the power of a negative number, we can use the chain rule to differentiate this. And so the next step is to let u equal the function inside the brackets, which is 2x cubed plus x. And so du dx, deriving this, is going to be 6x plus 1. And so then we have y is going to equal u to the power of minus 2. Deriving this, dy du, is going to be minus 2 times u to the power of minus 3. And so using the formula, we have dy dx is equal to dy du times du dx. And so plugging this into the formula, we're going to get dy dx is equal to dy du, which is minus 2 times u to the power of minus 3 times du dx. Du dx is 6x plus 1. Now just a side note, this is where most students lose marks. Whenever you have more than one term, always get into the habit of writing these terms in brackets, because this is different to writing it as minus 2 times u to the power of minus 3 times 6x plus 1. This would be a wrong answer. And so coming back to the question, we now do the final step where we replace u with its original function. And so this will be minus 2 times u, which is 2x cubed plus x raised to the power of minus 3, and then times 6x plus 1. And there's no need to simplify any further. And now for the second, quicker method. If we have y is equal to some function f of x, and this is raised to a power, then for this method, we kind of treat f of x as one term. And so we derive this using the power rule. And so dy dx is going to be n times, and then we write f of x raised to the power of n minus 1. And so we drop the power, multiply it to f of x, and we treat this as one term, and then take 1 off the power. And now the only difference is that from here, we multiply this by f dash of x. So using this second method, let's see how it works using the same function as before. And so we had y is equal to 1 on 2x cubed plus x raised to the power of 2. And so the first step is to rewrite this in power form, which is going to be 2x cubed plus x to the power of minus 2. And so dy dx is going to be, and so we treat the function inside the brackets as one term. And so this is going to be minus 2 times 2x cubed plus x, and then raised to the power of minus 3. And this time we multiply it by the derivative of the function inside the brackets, which is 6x plus 1, giving us the same answer as before, only in one step. So that's it for this video. Thumbs up if it was helpful, and I'll see you guys in the next video.